Two cricket batsmen, same average, 40 runs per match. Batsman A scores 10, 70, 5, then 75. Batsman B scores 38, 41, 39, then 42. Same average. But will you trust them to deliver equally in the match day? The mean can't tell them apart, but there is a measure that can. It's called variance, and it's square root standard deviation. Let's begin. The idea is simple. Measure how far each value traces from the mean, and that gap is called a deviation. That is basically each value minus the mean. But there is a problem. Some deviations are negative and others are positive. So if you just add them up, they cancel out to 0. So how do we fix that? It is simple. Square every deviation. Squaring makes everything positive, so nothing cancels out. Now the variance, which is sigma squared, will be given by the summation of all the deviations squared divided by n. Now then, to get to the standard deviation is much easier. The standard deviation is basically sigma, and it is the square root of the variance. A smaller deviation basically means values cluster tightly around the mean, while when we have large standard deviation, it means values are scattered widely. Let's calculate it. 5 values, 4, 8, 6, 5, 7. The mean for this case is 6, and to get it is very simple and interesting. We add all these values, and that gives us 30. Then we divide by how many numbers we have. Notice that we only have 5 numbers, so that shall be 30 divided by 5, and we get our mean as 6. Next, we subtract the mean from each value, then we square that deviation. For instance, 4 minus 6 is negative 2, negative 2 squared is 4. 8 minus 6 is 2, 2 squared is 4. 6 minus 6 is 0, 0 squared is 0. 5 minus 6 is negative 1, negative 1 squared is 1. Lastly, 7 minus 6 is 1, and 1 squared is 1. Then we add up the last column, 4 plus 4 plus 0 plus 1 equals 10. To get the variance, we divide this value by 5 and we get the variance as 2. Then to get the standard deviation, it will be basically the square root of 2, and that gives us approximately 1.41. There is a faster shortcut formula that skips computing every deviation. Variance equals the sum of the squares over n minus mean squared. So the variance shall be 16 plus 64 plus 36 plus 25 plus 49 divided by 5, then minus 6 squared. And that gives us 38 minus 36, which is exactly 2. The same answer we got using the previous method. Now let us tackle grouped data. Remember our 40 students and their marks. We already found the mean was 28.5, so let's find the spread. The step deviation formula for variance is h squared over n squared in bracket n multiplied by the summation of fy squared minus summation of fy in bracket squared. Now remember, to get the assumed mean, we pick any value from the midpoints, and for my case, I've picked 25. So to get y, it is x minus 25 over 10. So for the first value of y, it shall be 5 minus 25 over 10, and that gives us negative 2. For the second value, it shall be 15 minus 25 over 10, and that gives us negative 1. We do the same for the whole row. Next, we get fy. To get fy is simple. We multiply this column and this column. So for our first value, it shall be 4 multiplied by negative 2, and that is negative 8. For our second value, it shall be 6 by negative 1, and that is negative 6. And we do the same for all the remaining values. Then we get fy squared. Remember, we have y, but for this case, we need to multiply with y squared. So the first thing we do, we square the value of y, then we multiply the result by the f values in the same row. For instance, negative 2 squared, that is 4. 4 multiplied by 4, that is 16. Next, it shall be negative 1 squared, that is 1. 1 multiplied by 6, that is 6. Next, it shall be 0 squared, that is 0. And 0 by 10, that is basically 0. And we do the same for the remaining two values. The summation of fy is 14. The summation of fy squared is 66. Then n is the total frequency, and it is basically 40. Substitute the values in our formula and we shall have sigma squared being equal to 10 squared over 40 squared in bracket 40 multiplied by 66 minus 14 squared. And using our calculator we get this as 152.75 as our variance. To get the standard deviation we get the square root and it is approximately 12.36. So this basically means that a typical student deviates from the class average of 28.5 by 12.36 either direction. Let's return to our two boltzmann. How do we properly compare their consistency? We use the coefficient of variation, standard deviation divided by mean multiplied by 100%. A lower coefficient of variation means more consistency relative to that data set on average. Boltzmann A has an average of 50 with a standard deviation of 15 and Boltzmann B has an average of 40 with a standard deviation of 8. So the coefficient of variation of Boltzmann A shall be 15 over 50 multiplied by 100 and that gives us 30%. For Boltzmann B it shall be 8 over 40 multiplied by 100 and that gives us 20%. Even though Boltzmann A scores more on average, Boltzmann B is the far more reliable, consistent player. Let's bring it all together. Variance is the average of square deviations from the mean. Standard deviation is the square root of the variance and is basically in the same unit as your data. And lastly, the coefficient of variation helps you compare consistency across different means. Before you go, try this yourself. Find the variance and standard deviation of this dataset. Find the mean first, then the deviations, then square them. Pause this video and try it now. Here are the answers. The mean is 6, the variance is 2.8, and the standard deviation is approximately 1.67. The mean tells you where your data is centered, while the variance and standard deviation tells you how much you can actually trust that center.